So now we've loaded our sample into the DelsaMax Pro instrument. It's time to go into the software and begin to analyze the data and run the experiment. There's a number of different experimental options and parameters that we can adjust with this DelsaMax Pro in order to explore a wide range of applications. But let's take a look at one standard example with the particle size beads that are 50 nanometers in radius. So now we have our standard L50 latex beads loaded into our DelsaMax Pro instrument, and we're ready to begin analysis. These L50 beads on their assay sheet have a standard size of 42 nanometers in diameter or 21 nanometers in radius. To start the experiment, it's very simple. We open up a new experimental file. I'm going to tell the software which instrument to connect to. And then I just press this button on the upper left-hand side, and that connects the software to the instrument. It's indicated by a green light flashing on here. This is the start button. We're able to set the initial parameters on the left side here, but we'll run with the defaults for this first run. It's 5 seconds of analysis, 3 times over, 15 seconds total to get the dynamic light scattering and zeta potential. To start the run, all we do is press this green button. While the red light is flashing, that indicates that the instrument is running the experiment and collecting data. Typical dynamic light scattering experiments might take several minutes, up to nearly 15 minutes in time to collect zeta potential. But for this instrument, all the data is now collected, and it took only 15 seconds. This is the data log table, which has customizable font. I like to set it to 20 for easier reading. We see that the radius of our beads was 23.1 nanometers. This is very close to expected radius of 21 nanometers. We were also able to derive the zeta potential of the standards, which was 28.37 millivolts. This is right on the borderline for stable particles versus unstable particles. If we want a visual of our graph, we can look at the correlation graph by clicking this button on the top row here. And this gives us a view of our correlation curve. By clicking on measurement 1, which was our first measurement in the software, I'm able to adjust the limits of analysis for this correlation curve. Now, if you remember earlier, I mentioned that the slope of the curve is related to the nanoparticle radius that is directly measured. So for some experiments, for very large particles or very small particles, the default settings are not perfect. So what you can do is actually adjust these limits of analysis to the left for smaller experiments, for smaller particles, where the correlation curve will be shifted left, or you can adjust the limits of analysis out to longer time intervals for particles that will have longer correlation curves, and they'll have correlation curves that are shifted to the right. But the standard measurements of around 1.5 microseconds out to about 10,000 microseconds work well. So this data log table also has customizable font, which again I like to adjust to 20 for easier reading. It's just a few nanoseconds to collect all this data. If we want a graphical representation of our beads, we're able to look at a histogram, and this is trying to detect as many different species in the sample as possible. So this actually identified 2 peaks, one at 20.7 nanometers in radius. And let's increase this graph size once again so that it's more readable. And we can actually highlight the diameter on here. So one has a radius of 20.7 or 41.4 nanometers in diameter. And these are our standard latex beads. Well, remember we measured the zeta potential was right around minus 28 millivolts to minus 30 millivolts. This indicates that there will be some aggregation of our beads, and that's actually being picked up here a little bit as this second peak at 318.2 nanometers, and that's going to be from aggregated beads due to their lower zeta potential. At this point, we've analyzed our standards. both from a quantified standpoint on the measurement table up here. We've also viewed the correlation graph and the regularization graph. We can look at the mobility of the standards. By clicking here, we see the data points collected from 31 independent zeta potential detectors in the DelsaMax Pro. If we want to see what each detector came out with, we go on our left side and we can click on PALS. And this gives us an indication of all 31 detectors. For a strong zeta potential, we'll see all 31 curves neatly aligned. This is a size standard, however, that we're looking at, so it's not really meant as a mobility standard, which we'll run next.